couple streams ago, I implemented some basic text rendering, and we were using kind of the most primitive form of text rendering, which is to render text on the CPU side to an SDL surface, and then render text from the surface into a texture on the GPU side. There's nothing wrong with it in general. However, if you are constantly changing the text, you're going to be re-rendering to a surface and then re-rendering to the GPU every single frame. There is a more efficient way to do text rendering with SDL TTF. We're not going to be doing render text blended anymore. We're going to be using the text engine. So the TTF text engine, it's a text engine used to create text objects. And what we're going to be doing is essentially skipping the rendering to surface, and we're going to render directly to some renderer using a text object. The engine creates text objects, and the engine also renders these text objects to a specific renderer. We can use the text engine to render directly to surfaces. That's what we were doing previously. And then from surfaces, we used SDL to render to a texture. What we're going to be doing now is using the SDL 2D renderer, because we have a renderer created already. We're going to be rendering directly to the 2D renderer using the text engine by calling the TTF create renderer text engine. And then we can basically live entirely natively on the GPU if we wanted to. However, I'm not going to do that. We don't really need that level of sophistication. Maybe we'll extend this for now. So we'll have a pointer to SDL3 TTF text engine, and we'll set that from main. And the return value returns a pointer to TTF text engine or null on failure. So we need to check the return value here. And we'll pass in a pointer to the text engine on the platform side. So before the renderer, we will say DL3 TTF destroy render text engine, and this will be platform.text engine. One of the special ways that the text engine works, which makes it efficient, is that it builds a texture atlas behind the scenes, and it does this by caching glyphs. Caching representations of characters, essentially rendered characters that we have previously asked to draw text with. And so one of the things I'm thinking that we do is when we create our first text object, we actually just pass it A through Z, lowercase capitals, 0 through 9, maybe some punctuation. If we cache up front instead of on demand, that should reduce any sort of performance hiccups when we print a string with, let's say, some rare characters or something that causes us to regenerate text objects. So we need to save off the text object because we don't want to lose it across frames. So it needs to be in persistent storage. Maybe just put it into the game state. So maybe in the game state, we will actually have a struct text. We can have the object and we can have the font. And we'll have game state text font be SDL3 TTF open font. Maybe save off the point size here. Point size is going to be a float. Okay, so we'll have an F32 here. This will open the font, and we will need to make sure that we don't fail. So check for null. Now, technically on game shutdown, we do want to release these assets. However, when the game's shutting down, the application will be shutting down. So I think I won't even bother. And dynamically computed strings do not cast *U8. Only literals do. And I think what we need to do is this: C string, to C string. To C string, that's what it is. Okay, and attempted allocation with default allocator. Yes, thank you. So that's good. Our guard for default allocator helped us out there. Allocator is temp. Oh, I don't think it's assets. I think it's data. There we go. So we've loaded the font in now. GS text object is SDL3 TTF create text. And we pass in the engine, platform text engine. And then we pass in a font, which is BS text font. Then we pass in, we call it a primer string. Primer string is a string, and end of string, end of string. We'll have the alphabet in lowercase and then uppercase and then numbers. And then maybe exclamation mark, question mark, comma, period, colon, and parentheses, and maybe braces. Oh, I guess I'll need a space as well. I guess I'll put the space in kind of an obvious place, which is between these two guys. When we want to actually render something to the screen, it's going to be set text string. TTF set text string, we take in a text object, and then we take in the string to use to set the text, and then length is similar. It's going to be 0 for null terminated strings, or the string count otherwise if we have some sort of non-null terminated buffer or a substring or something like that, a view, right? And this function may cause the internal text representation to be rebuilt. My understanding of when things are rebuilt are when the cache is missing glyphs that the incoming string has. So the cache for the text object is missing glyphs, or when it comes time to render, if we ask to render in a new style like bold or italic or something like that. I don't really plan on doing either of those things. If I do have a cache miss, despite this massive string here, that's going to be too bad, but it's not going to be the end of the world. This is kind of a micro optimization, I think. So in update here, this is where we'll hack this in for now. Set the text string on the game state text object. We'll just use a sample string for now. Foobar, and then length, that'll be null terminated. So we'll set the text string on the GS text object here. And then we say TTF draw rendered text. We probably do not need to set the text string every single frame, but I'm going to do it anyway, just while we're hacking this stuff in. SDL3 TTF draw render text. And then we pass in the text object and the float XY. I don't know, we can just say X will be 50, Y will be 200. And let's run this. So there it is, drawing. Curiously, this is not getting super blurry as we scale up. Let's change the point size to see what happens. Change it to 10, just see what it looks like. I think there is a little aliasing, maybe. I drew some assets for a text box. Basically, the perimeter here are the boundaries or the borders of the text box, and then the green in the middle would just be the background, and this is where text would be drawn over. But in order to figure out the size of this that I want to draw, I will need to query the size of the text object. Here we go. Okay, get text size. We pass in a text object, and then we can get the width and the height. And then we can use those to dynamically figure out how large the backing text box needs to be. This is a tile map here. I will need to actually modify my tool that converts these to binary files and makes this available to the game via game data. And then I'll need to load in the texture atlas. We will have a text box, and this will be an asset tile set. So first things first, I think I need to extend my ASprite tool, source dest pair, to look into assets dir text, and then the dest dir will be our build dir, and then text. Textbox tile map is an asset tile map. Load tile map. This is going to take a renderer, and then we need a tile map. The textbox tile map path is going to be string join game state base path, and we're going to cap that with data text. Textbox bind, I think it is. Okay, is SDL3 TTF get text size. And we need the text, which is game state text object, and need a pointer to text width and a pointer to text height. Undeclared identifier, I30, oh, it's S32, right? Render text box. Then we'll call this down here. We're going to need the width and height of the text, and then we're going to have to pad that a little bit because the width and height of the text need to fit within some space that is just this green box. So we're going to duplicate this green tile horizontally and vertically as many times as we need to encompass the text. And then we will decorate the outside of whatever rectangle we create with the padding here. Attempt to display arguments to a non-polymorphic struct. Right, I have the syntax all wrong again. Been writing Jai every single day for months now, and I still get this wrong. That's a me problem. For starters, as I mentioned, I'm going to ignore the perimeter and just draw the green background on this guy. We need a renderer. We need text width, which will be an S32, and text height, which will be S32. These might even be floats. We'll figure that out later. And then we need the text destination. Maybe that comes first. We do also need to take in the tile set. We don't even need the number of tiles, right? Because this is a solid color, we can actually just take this single tile and we can render it the size of the text width and text height. Let's comment this stuff out for now and just do the really simple thing. So source is going to be an SDL frect, the text destination.x, text destination.y, cast to float 32, the text width pixels, and another cast to float 32, the text height pixels. Destination is going to be, nope, I got that wrong. This is actually destination. The source is going to be an index into our tile set. For X, that's going to be the text background index. I guess let's say 4.0. Modulo, well, can't be 4.0. It's got to be 4 because we're going to use the modulus operator. Modulo, the textbox tile set, the atlas width and tiles. And then Y will be the text background index divided by the textbox tile set atlas height tile. I guess this does need to be width. We need to cast this, by the way. So I guess we need to cast the float 32 here as well. We don't draw anything. No. Okay, we need to multiply by the number of pixels, right? This needs to be multiplied by the tile width, and this needs to be multiplied by the tile height. And there we go. So now we are drawing the background behind the text for the text box. We know, if I use this as our diagram, we know that this is the, like this point right here, I can zoom in even more, that this point right here is our 0, 0 in this text box. Let's see, I can blow this up too. And so then we just go back by 1 width of tiles and up by 1 width of tiles, and we render this guy. And then we go across the top, we run across the top the width of the text box, and we render this guy. And then we kind of repeat that. We go to the width, and then we subtract 1 tile height, and we render this guy. Okay, so let's do that. This is going to be an issue here because this the verticals on the left and right are rounded. These need to be straight because we don't know the total height of the text box. Right now, we are just stretching the background tile here across the text width and text height, but it's not necessarily evenly divisible by 16. For the destination, we do need to pad this out a little bit to make it an even multiple of 16 that is greater than the width and the width dimension and the height dimension. This way, when it comes time to actually put the decorators around the text box, everything is going to align nicely. We're not going to have any off by 5 or 10 pixel issue or whatever, something like that. I'll come up with a better name. We'll just call it F right now. This guy is going to take in, let's say, a tile dimension. So it's going to be a U16 in our case. And it also takes in textdim, which is going to be an S32. I guess we're returning S32. We return textdim plus textdim modulo fast S32 tile dim. As you can see, we are overdrawing here. So we've padded the background to some even multiple of 16. I do want to look at what the bounding box was though, initially. So to do that really quickly, you just return untransformed value. Take a look at it again. Okay, so we already had some overdraw. I see, that's really interesting. The bounding box for the text actually has some extra space to the right and to the bottom. The way that we center this thing, for example, is we can take this value, which is the adjusted value. We can subtract the text width pix from it, and that gives us the difference. We can divide that by 2. The adjusted x will take the padded width minus the text width in pix divided by 2. So we can probably do the same thing for y. We text desc y minus padded height pix and text height pix. And we can just do like some stretch tricks for the top and the bottom, the left and the right, and then for the upper left and the upper right and the bottom left and bottom right, we'll just draw a single tile, get source rect. And what this takes in is an index, which we are saying is a U64 atlas with tiles, which is going to be also U64, and tile width pix, which I think is a U16. My types are all nasty. I need to also normalize those. And tile height pix, which is a U16. And this will just be index. This will be atlas width tiles. This will be tile width pix, tile height pix, tile width pix. So we didn't return this guy. This is going to be SDL3, SDL FREC. What I will do is just render maybe one of the corners, and then I'll render across the top of the box, and then I'll probably end the stream just because the rest of the stuff is just busy work. And there's the corner. So the corner is in the upper left. This is programmer art, so this is going to look pretty nasty. Yeah, I guess I would have to loop if I want to repeat that texture. It's definitely going to be a lot nicer to stretch it. Num tiles is going to be the padded width. This will divide evenly now because it's padded, divided by the text box tile set tile width pix, and then 0 to num tiles minus 1. We have the source is going to be the same. The dest is going, we're going to update the dest here. We're going to march the x along the upper row. The y is going to stay fixed, which is going to be adjusted y minus the text box tile set height pix. The tile we draw is always going to be the same dimension, so we just need to march the x here. So we're not going to do any minusing. We're going to be doing plussing. Plussing of it times, so the iterator times the tile width pixels. That would be the destination in the back buffer. We will build, we will run this, and it did not do what I expected. Oh, okay. I put it in the wrong scope. All right, it is time to turn in. It is time to turn in, that's for sure. And it's stretched. Okay. All right. So I think that's evidence that it's time for me to put it away for the day. Have a good rest of the day. Cheers.